Hi guys. Okay, so today we're going to look at implicit differentiation. So implicit differentiation is the technique we use to find a derivative when y is not defined explicitly in terms of x. So in other words, it's not y equals, okay, but it has to be differentiable. For instance, if you look at this example, x squared plus y squared minus 9 equals 0, we really don't want to have to solve that for y. Okay, because you'd have to take the square root of both sides, there'd be plus and minus the square root of both sides. It gets really messy. So it's nice if we can take the derivative without having to solve for y. So here's the first step. We differentiate, which means take the derivative, both sides with respect to x. So we take the derivative with respect to x of both sides, okay? So for instance, we're going to take the derivative with respect to x of x squared plus the derivative with respect to x of y squared minus the derivative with respect to x of 9 equals the derivative with respect to x of 0. Now I'm going to be honest here. This step, I'm writing it so you see it. You don't ever have to write this step again. Okay, but I want you to understand what it is we're doing. Because now we're actually going to take the derivative. So the derivative of x squared is 2x plus, now the derivative of y is 2y times dy dx. Because remember, y is a function in terms of x. So there's x's hiding inside of y. You have to use the chain rule. So this is using the chain rule here. Okay, you take the derivative of y squared, but don't forget to take the derivative of y. Next step, minus the derivative of 9 is 0 equals the derivative of 0 is 0. So we don't need this 0. Next step is to solve for dy dx. So everything with a dy dx is going to stay on this side, and everything without a dy dx is going to move to the other side. Then we're going to have to divide both sides by 2y. So dy dx equals, and don't forget to simplify. So here we're going to put step 3, simplify if possible. Okay, so this would be negative x over y. So here is our derivative. Now there's a couple of things I want to take a look at. First thing is, I want you to go back and look at this. Remember, that's really x squared plus y squared equals 9, right? That's a circle with a center at 0, 0 and a radius of 3. So if you look at this, it looks like this at 3, 3, negative 3, and negative 3. Now, I've got a couple of notes here that I want you to think about based on this derivative. The first thing I want you to think about is, when does the derivative not exist? The derivative does not exist when the denominator is 0, so when y equals 0, okay? That's when you're going to have vertical tangents. And if you look on the graph, we've got vertical tangents here and here. So in this case, it's at the point negative 3, 0 and the point 3, 0, okay? Which you would get by substituting y equals 0 into this equation and solving for x. Also, I want you to notice, when does the derivative equal 0? That's when the top is 0 or when x equals 0. And if the derivative is 0, that's when you're going to have horizontal tangents. So it's really important to remember, if the derivative doesn't exist, you have vertical tangents. If the derivative is 0, you have horizontal tangents. And notice we're going to have horizontal tangents at the top and the bottom. So on this one, it's at 0, negative 3, and 0, 3. Okay, nice. Ready for some more calculus derivatives? Woohoo! Okay, here's one. X sine y equals cosine x plus y. So it's important to realize that this is x times sine y. We're going to have to use the product rule here. So the product rule says the derivative of x is 1 times keep the sine y, plus keep the x. The derivative of sine y is cosine y. Don't forget also, you have to use the chain rule, because what is the derivative of y? It's dy dx equals, derivative of cosine is negative sine, keep the angle x plus y, times, what's the derivative of the angle? The derivative of the angle x is 1, plus the derivative of the y is dy dx. Now, in order to solve for the dy dx, we're going to have to take this and distribute it so that we can get it written with the dy dx. So we really have sine y plus x cosine y dy dx equals negative sine of x plus y minus the sine of x plus y dy dx. Now we're going to take everything with a dy dx and move it to the left, and it doesn't matter which side. I'm going to move it to the left, and we're going to take everything that doesn't have a dy dx and make sure it's on the right. So what we have is x cosine y dy dx, but I'm going to add the sine of x plus y dy dx equals, and I'm going to bring over that negative sine y, and I still have minus sine of x plus y. Now, we can see here that dy dx is a common term on that side, so we're going to factor out the dy dx, and what's left if we take that out? We're going to have x cosine y plus the sine of x plus y equals negative sine y minus the sine of x plus y. This is messy looking, isn't it? And the last step to solve for dy dx is to divide. So I have negative sine y minus the sine of x plus y all over x cosine y plus sine of x plus y. Wow. Beautiful. All right. Okay, let's take this implicit differentiation and use it to find the equation of the tangent line to 9x squared plus 16y squared equals 144 at the point where x is 3.2 and y is greater than 0. All right, so we're going to start with 9x squared plus 16y squared equals 144. When we take the derivative of 9x squared is 18x plus the derivative of 16y squared. 2 times 16 is 32, y to the first times the derivative of y is dy dx equals the derivative of 144 is 0. So we first bring the 18x to the other side, so we subtract it. Then we're going to divide both sides by 32y, and we're going to simplify, right? So dy dx is negative 9x over 16y. So here's my dy dx, right? Because if we want a tangent line, we know we need the x value, which is 3.2. We know we need the y value, and we know we need the slope, which is the derivative evaluated when the x is 3.2 comma whatever the y is. We still have to figure that out because I don't know what the y is. But I know that at x equals 3.2, we're going to find y. So here we go. We're going to use the 9x squared plus 16. We're just going to use the original function they gave us. So it's 9 times 3.2 squared plus 16y squared equals 144. Feel free to use your calculators here. 92.160 plus 16y squared equals 144. So 16y squared is 51.840. So y squared, I'm typing this in my calculator, 3.24. Now we square root both sides and we get a positive and negative 1.8. However, we know that y has to be greater than 0, so our y is 1.8. Now we have the y value. Now to find the slope, we're going to take that. The slope is our derivative evaluated at the point 3.2, 1.8. So 3.2 is going in for x and 1.8 is going into y, and we're using this derivative. So it's negative 9 times the x is 3.2 over 16 times the y is 1.8, and you're going to throw that in your calculator, and lo and behold, you get negative 1. So the slope is negative 1. Now our tangent line, we're going to use the point slope form of our equation of a line, and it's y minus 1.8 equals the slope negative 1 times x minus the x value, 3.2, and there we go. We have the equation of a tangent line. Whew. Okay, I have one more problem here, and this is a free response problem, okay? Now notice they ask you to consider the curve defined by y squared minus x squared y equals 6 when y is greater than 0, and that's important. We're going to circle that. And notice it says show that dy dx equals 2xy over 2y minus x squared. They told you the answer. They told you the answer, and you now just have to apply the rules. So you know what the answer is supposed to be, but don't make up the work in between, because we're going to be looking at the work. The derivative of y squared is 2y dy dx. Now be careful, you're going to have to use a product rule here because it's negative x squared times y. So the derivative of negative x squared is a negative 2x times keep the y plus keep the negative x squared times the derivative of y is dy dx equals the derivative of 6 is 0. Now, everything that has a dy dx is staying, everything that doesn't is going over here. So this is going to be equal to 2xy. But not only that, I see that these two terms have a dy dx, and if it's okay, I'm going to do this in one step. I have 2y minus x squared, and if you need 2 steps to do that, that's absolutely fine. And now all I have to do is divide both sides by that 2y minus x squared, and I have shown what they asked me to show. Ta-da! It works. Okay, now part B. Write an equation for the line tangent to the curve at the point 1, 3. So if they gave us the point, we know that the x is 1 and we know that the y is 3. So we need to find the slope, which is the derivative evaluated at the point 1, 3. Now remember, our derivative is 2 times the x value is 1 times the y value is 3 all over 2 times the y value is 3 minus the x value is 1 squared. So 2 times 1 times 3 is 6 over 6 minus 1. That gives us 6/5. So y minus the y value is 3 equals the slope times x minus the x value is 1. And here's the equation of your tangent line. Part C. Show that there is a point with an x coordinate 0 at which the line tangent to the curve at P is horizontal. Now remember, if you have a horizontal tangent, that means that the derivative is 0, and we have to find the y coordinate also. So if the derivative is 0, that only happens, remember, our derivative, dy dx, is 2xy over 2y minus x squared. The derivative is only 0 when the top is equal to 0, okay? Well, that means that either x is 0 or y is 0. Well, this is what they wanted us to show, so we have that. However, remember, we were also told at the beginning that y had to be greater than 0. Remember that? Back here at the beginning, y is greater than 0. So y equals 0 is not in our range since we were told y is greater than 0. Okay, but we showed that we do have a horizontal tangent line when x is 0. Now we have to find the matching y value. So we're going to take the function they gave us, y squared minus x squared y equals 6. And we're going to let x be 0 so we can find the matching y value. Y squared minus 0 times y equals 6. So y squared equals 6, which means y equals plus or minus radical 6. However, we know that y has to be positive, so y is the square root of 6. All right, 3 out of the 4 parts done. Now comes part D. We're going to find the value of the second derivative of y with respect to x twice at the point found in C. So we're looking for the value of the second derivative at the point 0 radical 6. Okay? Well, let's write down our dy dx. So our first derivative dy dx was 2xy over 2y minus x squared. So we have to use a quotient rule. The derivative dy dx is the second derivative of y with respect to x twice. Now, quotient rule says take the derivative of the top. But in order to do the derivative of the top, we need to do a product rule. So the derivative of 2x is 2, keep the y, plus keep the 2x, and the derivative of y is dy dx. So that's the derivative of the top, times keep the bottom, minus keep the top, times the derivative of the bottom. The derivative of 2y is 2 dy dx, minus the derivative of x squared is 2x, all over the bottom squared. Now, guys, you're supposed to be finding a numerical value. You're plugging in these numbers. Do not try to do the algebra and simplify. You're only going to make your life more difficult. Once you've applied the calculus rule and taken the derivative, start plugging in numbers, okay? But I also want to make a note for you over here. See this first derivative? Because we have dy dx is here and here. The derivative at this point 0 radical 6, we know that this is 0. That's how we found it, right? And anyway, because if you do it 2 times 0 times the square root of 6 over 2 times the square root of 6 minus 0, it's just 0 because the top is 0. So now let's plug in. We've got 2 times the y is the square root of 6 plus that dy dx is 0, so I'm not even going to worry about, and so is the x, so I'm not going to worry about that, times 2 times the y value is the square root of 6 minus x is 0 squared minus 2 times x is 0. Now, if you're smart, you realize nothing else after this 0 matters because everything's being multiplied by 0. So this whole second part here is going to become 0 because of that piece. All over 2 times the y is the square root of 6 minus 0 squared, all squared. Okay, a little bit more algebra here. So we've got 2 rad 6 times 2 rad 6, okay, minus 0, so I don't have to write that, all over 2 radical 6 quantity squared. Well, guess what? That numerator is equal to the denominator. Our second derivative value is 1. All right, guys, we did a lot in there, and take it slow. Don't forget the chain rule. Don't forget to look for where you have to use the product rule. All right, have a good night. See you soon, guys.